Okay, so we've seen that we can replace, if we've got to find the integral of cos squared x, we can replace cos squared x from the last lesson with a half plus a half cos 2x dx. So that's not the integral, that's just the substitution we make because there's no rule as such for integrating cos squared x. That's a 2 there. Let's rub that out. Do it again. Alright, so that's from the last lesson, that's what we found. And now we need to integrate that. So the integral of a half is a half x. Now let's work kind of from the middle. The integral of cos is sine. So we know there's going to be a sine there, and the 2x just follows. And then we've looked at differentiation of trig, so therefore it's the opposite. So the derivative of sine 2x, well, what happens in trig differentiation? If we're finding d dx of sine 2x, we derive what's after the sine. So the derivative of 2x is 2. We change the sine to a cos, and we rewrite the 2x. So now we're going the other way. We've got a half cos 2x. That's what our answer needs to be. A half cos 2x. So we just need to fiddle that number. So essentially in integration, instead of timesing by the derivative of the 2x, we divide by it. Similar to normal integration if you think about it. Okay, if we had the derivative of x to the fourth, the derivative we times by the 4 and we minus 1. The integral of x to the fourth, we add 1 to the index and we divide. So the same thing comes with the trigonometry. So I'm just going to get rid of all that now. So back to where we were. So we divide now by the derivative. It's the opposite operation. So the derivative of sine 2x, well, the derivative of 2x is 2. So we're going to divide by that 2. And there's also a half there. So if we divide by that 2, and there's also a half there, that's going to give us a fraction of 4 plus c. A denominator of 4, sorry. So that's a half x plus a quarter sine 2x plus c. So that's our integral of cos x, cos squared x. You can remember that if you want. Best not to. Best to derive it every time, I think, because those times are going to be few and far between in exams. And now we look at the integral. Wrong colour, Mrs. Buxton. The integral of sine squared x. Well, what we did in the last lesson, we can replace sine squared x with a half minus a half cos 2x. So that is something you can remember. They're identical, just about, apart from the sign. So I should have put that integral, whoops, no. That integral sign in there. And a dx. Okay, and then we're going to integrate this, which is very similar to the cos. So it's a half x. Now again, we work from the middle. So we've got a minus cos. So the integral of minus cos is a minus sine 2x. And the last bit is we divide by the derivative of what's being signed. The derivative of 2x is 2. So we divide that, and like last time, it's going to be a quarter plus your c. So again, they're identical, only separated by 1 sign in front of that quarter. So as I said, be familiar with it, remember what it is, but I wouldn't commit it slavishly to memory, because what if you've got cos squared 2x or cos squared a quarter x? It's not just as simple as subbing something else into the equation. Okie doke, so that's the integral of cos squared x and sine squared x.